So I have a very brief slides, three slides. Regarding the agenda of what we plan to cover, just a little bit about background of myself and the context of what I'm going to present. Then I'm going to do just a very brief introduction on what's the serverless framework that I'm proposing to improve with Terraform. I'm going to talk about the limitations that I have found personally working with that and how Terraform can potentially solve those limitations. And I'll switch to showing a proposed workflow and what the code could look like. So regarding my background, my name is Stenio Ferreira. I'm a solutions engineer at HashiCorp. I have been here for a year. I come from a developer background. I'm originally from Brazil, but right now I live in Chicago in the US. And once a month I play in a heavy metal band. So this is a picture of me last year. I was singing Typo Negative Black #1. If you're interested in finding out more about me, I'm Stenio123 on Twitter, GitHub, and all the social medias. So regarding context, the format of this presentation, I decided not to do slides because when I presented this to a prospect, it was in the same approach, and I felt it was more seamless. But if you have any questions afterwards, or if you like something more hard copy, just reach out to me and I can provide something. Regarding my choice of presenting this with Terraform Enterprise versus open source is because my argument is that serverless is great for smaller projects or for individuals, smaller companies. The problems start to appear when you switch to this enterprise context, when you have large teams, you have compliance requirements. And when you're in that context, Terraform Enterprise has certain features that make it much more seamless. So some of the things that I'm going to present here, like modules, can be applied in Terraform open source, but the entirety of the solution that I'm proposing is better suited for Terraform Enterprise. So let's do a whiteboard. In the beginning, there's Lambda. So let's assume this is AWS, and you have a Lambda function here. So for those of you that don't know what a Lambda is AWS service where you can upload a function, and instead of having to manage a virtual machine, you just have that function living in AWS, and it can be triggered by a certain event. So in the most base use case, you're going to have your developer that writes app code. So this is my app code. They are going to generate a zip file, and they're going to upload this actually to S3 bucket, and then eventually becomes a Lambda. So this is the most simple use case. The thing is, this Lambda is very limited. The only thing probably you'll be able to do is just output like a hello world to the AWS console, and that's pretty much it. So it's not a very realistic deployment. What most likely you're going to need to do is maybe you have a CloudWatch event, like something happens in AWS and you want to trigger your Lambda. Or maybe you want your Lambda to access S3 bucket. So in order to do that, you need to associate IAM permissions to your Lambda. Or maybe you want to expose this Lambda to the public, and now you're talking about having an API gateway. So once you start increasing the complexity of your Lambda deployment, AWS originally just had the option of defining this infrastructure as CloudFormation templates, and then it's a separate workflow for you to deploy this and manage your deployment. This was great, but then in order to make things easier for the developers, I believe that it was AWS, and then eventually it expanded. They created the serverless framework. I think this is a lightning bolt. So serverless is a binary that you're going to install. And with serverless, what's going to happen is instead of having these two workflows that the developer has to create, the app and generate the zip and upload everything, and then do the same with CloudFormation. They can just give the app code and the CloudFormation code to serverless, and serverless will be responsible for zip and uploading this to AWS. So before it was 2 workflows, now it's just 1. And moreover, serverless accepts a superset of CloudFormation. So it has some shortcuts. It's much easier to deploy. Before working with at HashiCorp, I use it, and it was great. So I really enjoy it, and I recommend for small projects. The challenges and that I face, so limitations. Number one, it doesn't scale well. And what I mean by that is, for small applications, it's great, but every time you make a change on your application or on your infrastructure, you're going to have to redeploy serverless. So it's going to run all your tests again, it's going to generate the zip, and it's going to push this upload. Like I said, for small applications, this is fine, but in a previous project that I worked on, it was a Node.js project, and we had a lot of dependencies, including Mapbox, which is a mapping dependency. So it was very large and bulky, and it was very unwieldy. The second limitation is hard to reuse. Once you create this CloudFormation, or even the superset of CloudFormation code, it's hard to take this code and share with other serverless deployments. In the end of the day, it becomes something very specific, and you end up just copy and pasting blocks of code. The other limitation is secrets. Well, let's say hard-coded secrets. So let's say your Lambda function is going to rely on environment variables to get database credentials or something like that. At some point, you're pretty much going to have to enter those secrets in your serverless configuration or in your app. That's a limitation. And finally, if you're talking about enterprise environment, it's hard to enforce compliance. So how can you limit the types of resources that can be described in serverless? How can you enforce that the resources are tagged? How can you enforce that a developer can only deploy in certain AWS regions? These are usually concerns for enterprises, and it's not something that serverless provides really well. So the solution that I'm going to propose is using Terraform. So there's certain features of Terraform, let's talk about Terraform Enterprise, that can make these limitations go away, or at least be easier to handle. The first one is we are going to start using the concept of workspaces. So instead of managing your app and infrastructure the same way, the same workflow, you can isolate the development of the app and the development of the infrastructure. And you can have independent infrastructure deployments. The second one is Terraform Enterprise modules. So Terraform Enterprise will have a private module registry where those snippets of code that you want to reuse, you can create modules, and those can be versioned. You can enforce restrictions of developers need to use a certain version, things like that. And finally, there's a Terraform Enterprise Sentinel. This is the tool that's going to allow you to do these guardrails, these compliance rules. So let me show you what Terraform Enterprise looks like. This is the software as a service version. So it's also by HashiCorp. There's also the private install, if it makes sense. So here you can see the different workspaces. And like I mentioned, workspaces represent a deployment. So it's kind of like a state file. And when you create a new workspace, you're going to give it a name, whatever name you want. And this is going to show the repositories that are available in the version control system that you have configured. Terraform Enterprise supports these guys, so all the flavors of GitHub, GitLab, or Bitbucket. Right now, I just have github.com configured. So it's my own account, and this is the repositories that I have in my account. So you can map a workspace to a repository, and that's it. Or you can be more granular and actually map to a certain folder in that directory. So maybe I have a /infrastructure or something like that. And you can also map to a certain branch. So in theory, I can have, let's say, 3 different workspaces They can be mapped to the same repository, but one can be to the dev branch, another to the QA branch, and another to the production branch. And once you create this workspace, it's going to create a Git hook. So whenever there are pushes to GitHub or Bitbucket, whatever your source control is going to trigger a Terraform plan followed by an apply. And then you can configure if you want to auto-apply or if you want to confirm the apply first. So this is Workspace, and another cool feature of Workspaces, you have these variables that you can set up here. So I'm going to show the module that we're going to use to deploy Lambda has environment variables available as a Terraform variable. So you could define those here. And when you create a variable here, you have the option to select a sensitive. So what that means, this is an example, my AWS keys. Once you enter them, you can't read, but it's available for Terraform to use. So now when you are talking about teams, this is a much easier way of sharing secrets and allowing the sensitive strings to be available to whoever needs. So Workspace is feature number one. Feature number two that I mentioned is this private module registry. So it's kind of like Docker Hub. It's a registry, a repository where you can store your snippets of reusable code, your Terraform modules. And the cool thing is, this is the one that we're going to use, you can version them. So right now I only have one version, but if there were changes to this and I push, I can add a git tag, and based on that tag, it would create a different version. So if I'm a developer, I can select which version I want to use, and I just need to copy this little snippet of code in my infrastructure, and that's it. I can leverage what was described here by a Terraform operator. And this lists the inputs that are available. And I'm going to talk a little bit more detail about this module in specific, but right now just showing the private module registry. And the final component, the guardrails, the one that allows you giving greater control of what can be deployed in an organization, is Sentinel. So these are a few examples of Sentinel policies that I have defined. It can be for any provider. So these ones are for AWS, so I can enforce mandatory tags, restrict IAM policies, restrict regions. It's very flexible on what you can accomplish. And once you create these policies, you can assign them globally. So it's going to be applied to every workspace or to specific workspaces. And just a final note on Sentinel, there's 3 levels. I can be just a warning. So when you run Terraform plans that, hey, there's something wrong. It can be a soft mandatory. So it's going to give you a warning and allow you to override, or hard mandatory. It doesn't allow you to override, it just fails. And Terraform Enterprise also has ACL control, so you can ensure that only admins will be able to change this. So enough about that. Let's talk about the workflow that I'm going to propose. So for this demo, I have created 2 Git repositories. One is the example itself, and the other one is the module that I'm going to use, that's deploy Lambda module that I was talking about. So in this code, there's 2 main folders, I guess, that I'm proposing. The first one is the app. This is where the Lambda app is going to live. And infrastructure, this is the infrastructure code. Once you have time, you can read all of this. It just gives some background. But I want to focus on the workflow. So what I'm describing here is the workflow for day 0. So that's the initial configuration. You're just starting a serverless project. And then I'm going to talk about the following day, once you have changes to the app. And then the following day, if you have changes to the infrastructure, how that will happen. If we were using serverless, it's pretty much the developer just changes either the app or CloudFormation and runs, and that's it. But now, since we're talking about enterprise, we start to have different roles, different responsibilities. So the workflow that I'm proposing, there's going to be a person that's the TFE publisher. So usually in an organization, this would be the cloud architect or somebody that's responsible for the patterns for your cloud deployment. And this person will be responsible for a Git repository that has the Sentinel policies. so those guardrails. And they are responsible for creating and managing the modules. So those are the snippets of code that can be reusable. And that's the deploy Lambda module that we'll talk about. And then the other role is the developer. So the developer in large organizations, they should be specialized. They should be working mainly with their application, and infrastructure should just work. But having said that, we are in the 21st century. They should have the ability to do small changes in the infrastructure if that's required for their app. So the way the day zero would work is the TFE publisher would register the module they have created and issue a tag for the version and register the Sentinel guardrails on Terraform Enterprise. The developer is going to create a new Git repository. And my suggestion is not required, but to organize, they can put the application logic under this app folder and Terraform under infrastructure folder. The Terraform information they're going to get from the module. So is this part that I showed here. We're going to use. So you pretty much just need this snippet of code, and then you can identify what are the variables you want to use. So what this looks like for me is I created this main and the variables. So in the main, you don't have to worry about this. Okay. This is the main thing that's important. So I'm specifying what module I'm using, what's the source, where it's coming from, which version, and then what are the variables that I want to use. For this particular deployment, just using the bucket, key, handler, and runtime. But I could also have set the environment vars, log retention days. So it's going to depend on how you implement the module, what functionalities you expose. Go back here. So that's day zero. And then if you want to continue having the functionalities of serverless where you can run a script to run unit tests on your application or integration tests, you can still tie that particular folder to a CI/CD application. And this is the application that's going to be responsible for zipping and uploading to S3 bucket. And it's going to be very simple. I have an example of the shell script. So pretty much just zip the application and create a bucket if it doesn't exist, and copy the zip to the bucket. If you want, you can expand here. You can add tests or do whatever. You can do something similar to what is done with serverless. It's very flexible. And this is my application. I think it's just a hello world. Yeah, don't do anything. You don't have to have a zip here. I just forgot to put a git ignore. So anyway, that's day zero. When you have changes to the app, you don't need to involve the TFE publisher. It's just the developer that needs to be involved. They can do changes to the application itself. And once there's a push to the Git repository, the two Git hooks will be triggered. The first one for Terraform and the other one for CI/CD. So the CI/CD is going to run first and uploads the bucket to the zip to the S3 bucket, and then the developer can go or a manager and approve this Lambda deployment in Terraform. If there are changes to the infrastructure, two things can happen. If these changes are going to impact other serverless deployments, so it's something that could be done on a module level, then it can be the responsibility of the TFE publisher. They can do the change on the repository and add a new tag, so upgrade the version and push it to Terraform Enterprise. And or if it's just a small change, just relevant to that particular deployment, the change can be made by the developer. They just change in the infrastructure. Maybe they are going to add something that's not available in the module. And same thing, it's going to trigger Terraform Enterprise, it's going to trigger a new Lambda deployment. So that's pretty much it. And so I showed what the code looks like. And this is the module itself. To create a Terraform module is pretty straightforward. It's just a deployment. So I'm using the Lambda resource, specifying some variables, the handler, runtime, environment variables, things like that. So you can specify all sorts of resources, and these are going to be encapsulated in a module. And here, I didn't have any outputs, but you can have outputs for further consumption. And that's pretty much it. So what I described here in summary is that serverless is great, but if you're in an enterprise environment, it can have these limitations. And Terraform Enterprise has certain features that help address those limitations. And in order to take advantage of those features, here is an example of the workflow, what it can look like, showing the different personas, the different roles and responsibilities involved. And now I guess we can switch to questions. Are there any questions?
There are some questions if you click on Q&A. Can Sentinel become AD LDAP aware group-wise access control to users in an enterprise?
Right. Yeah, the way that Active Directory integration works is when you're creating Terraform users, you can create them by hand. But if you're using the private module install, you can connect it to your Active Directory server. And then you can map those users different permissions inside Terraform. The users are the groups of users. So for example, if you have already a team of admins in your Active Directory already set up, you can map those to whatever would be the equivalent of admins in Terraform Enterprise. So Sentinel is mostly to constrain what resources are deployed. And then does Terraform Enterprise automatically update remote states if they are updated? So the way that Terraform Enterprise works is each workspace is going to have a state, and all those states are stored within Terraform Enterprise. So whenever, and here you can see a history of all the runs, plans, and destroys for each particular workspace. So answering your question, yes, whenever there's a change to the state of a workspace, it's going to be updated, and there's going to be a history in Terraform Enterprise. Here you can see a history of the states. Any other questions? Can I use Jenkins to call TFE workspace to run a job? Yes, so there are 3 ways that you can trigger Terraform Enterprise runs. I just showed one where you're using Git hooks, but Terraform Enterprise also has an API. So a user or Jenkins can actually make an API call, and that's going to trigger a Terraform Enterprise run. And the other approach, Terraform Enterprise, allows you to have enhanced remote state. So what that means is you're going to have a similar workflow that you're used to with Terraform open source. So you can use your Terraform binary, either a user or Jenkins. And instead of specifying your remote state as a S3 bucket, for example, you specify Terraform Enterprise. So then things are going to run as expected, but the state file is going to be stored in Terraform Enterprise, and you have all the benefits of the workspace. It's going to be available. I think I have one here that's deployed like that. So it looks like this. This one, remote backend master. So it doesn't have the repository associated because it's just keeping the state here. And if you're interested, just check my GitHub repository. I have an example that I forked from a colleague. Going to be, you just need to have Terraform Enterprise or access. Here, remote backend. So this is what it's going to look like. This is just like a basic Terraform that's not creating anything. But the main difference is that you're using this backend remote. And actually, this example is set up to use with Circle CI. So answer live. To apply TFE. Is Terraform Enterprise state always kept in HashiCorp service? For security, some organizations prefer open source alternative where Terraform state can be kept locally or in their object store. Yeah, so Terraform Enterprise, there are two versions. What I showed is the software as a service, and then yes, it's stored by HashiCorp, but things are going to be encrypted. If you use the sensitive variable, nobody can see it, use this vault behind the scenes. The other version of Terraform Enterprise is the private install. So private install, you get the package of Terraform Enterprise and you install in your data center or AWS or whatever you want. It's actually a container, the installation. And HashiCorp has no visibility on that. There's no pings or anything. It can be completely air-gapped. How to have multiple state files using only one Terraform blueprint folder? Well, you can map a single Terraform blueprint folder or Git repository to different workspaces. So each workspace is going to be an independent deployment, and you can set different variables for each workspace. So that's how with just a single, maybe you have like a networking deployment, but you have dev, QA, and prod. So those could be 3 different workspaces using the same networking structure. Can I import my vars into TFE variables? So TFE actually is going to look for your TF-vars file, but if you specify the variables in the workspace level, those are going to override. So that's one option. The other option is if you want to configure remotely or automatically configure instead of coming here and clicking buttons, you can leverage the, API calls to configure, to seed like your variables, or you can also use the Terraform Enterprise provider. So you can use Terraform to provision Terraform Enterprise. Let me show you. So you can create, define workspace and everything as a Terraform file, and you can manage it like that. So you could do it like this. Any other questions? We have 30 seconds. Thank you. Katie, I think that's it. Thank you very much for the opportunity, and thank you everyone that attended. And again, my Git repository, everything, just look for Stenio 123 and you find everything.
Thank you for taking the time to answer all the questions too. I know people love that.
Thank you.